All right, welcome to our talk. This is WEB306. We're going to be talking about UI testing, load testing, and performance testing your website on AWS. I'm Leo Jadnowski. I'm a solutions architect at Amazon Web Services, and I'll let Dave introduce himself.
Yeah, and I'm Dave Mozelles. I'm the quality assurance manager for Amazon Local.
So, first of all, why do we load test, right? Why is it even important? Well, the only way to really see how your application is going to perform at a certain level of traffic is to actually test it to that level of traffic. This traditionally can be challenging to do, but on AWS, it's actually fairly simple. The other really important thing is when you load test your application, you expose all kinds of information about your application. You expose bottlenecks. You see how it performs at scale. If you've built your application to be scalable, you see whether it's actually scaling up or down when it's supposed to be, and what happens, does anything break when that happens? So you need to do testing to figure that out. So here's what we're going to talk about today. We're going to talk about UI testing. So Dave's going to talk about that and how that's done at Amazon Local. Then I'm going to talk about load testing. And when you're load testing on AWS, there's some special considerations, depending on whether you're testing an Elastic Load Balancer or CloudFront, or whether you're testing if your auto-scaling groups work. And then we're going to talk a little bit about performance testing. So, what data do you get from your load test? How do you figure out what you need to fix, what you need to optimize? So we'll talk about CloudWatch. We'll talk about some application monitoring solutions that you can do. So I'm going to hand it over to Dave.
All right, so I'm going to talk with you guys today about how Amazon does automated UI testing. So why do automated UI testing? I'm going to just go ahead and answer this question and kind of follow with a couple other follow-up questions here. So why do UI testing in general? So the reason why we do UI testing is this mimics how a user is going to interact with your system. So it's the most assured way of providing end-to-end assurance that things are working properly. So that's why we do UI testing. So then why do we automate it? So the main reason in here is that manual testing doesn't scale. So at Amazon Local, we have 200,000 lines of code. We're deploying those 200,000 lines of code about once every 3 weeks. So when we're looking at that with that 200,000 lines of code, and that's continuing to grow as we're adding on features, how can we handle this without, how can we handle that scale if we're continuing to add features? So there's a couple options that we could go with. We could hire more manual testers, but obviously that doesn't scale. We could reduce what we test. So maybe we're not going to test all the features that during each sprint, which obviously as a quality assurance manager is not something that I'd be super happy about. Or we can automate the testing. Yeah, and again, the automated testing allows us to provide end-to-end assurance that everything is working properly. So what do you test at the UI level? So we don't, there might be a perception out there that, well, if automated testing is good, we should just test everything at the UI level, because then that's going to give us assurance that everything's going to be working at the UI level. But we actually don't do that at Amazon. So we do not try to test everything at Amazon. And the reason for that is if you try to add all of your tests at the UI level, they can actually become very difficult to maintain if your UI is changing frequently, as ours is at Amazon. Our UI changes very frequently as we're adding features, so the maintenance cost of adding UI tests and updating those UI tests can be high. So what we try to do is we actually try to take our tests and then we push them down as close as we can to the code. And if we can't test them at a lower level, then we'll look at testing them at the UI level. So what do we test at the UI level? So what we'll do when we're looking at a new feature that's going to be rolled out on Amazon Local is we'll take a look at what are the tests that we want to run to make sure that that piece of code or that feature is working. Then we'll look at what level does it make sense to test it at. So the first thing we'll ask is, can this be tested at the unit test level? So can I actually just write a unit test for this and then just validate that the function is working? Validate that it's working at the unit test level. And if we can't do that, then we'll look at the service level. So at the service level, we'll say, well, what are the tests that we can automate at the service level? And then at that point, if we can't automate it at the UI or the service level, then we'll look at testing it at the UI level. But again, we're not going to try to test everything here. What we would do is we'd look at all the test cases that we weren't able to test at the lower levels, and then try to figure out what are the most important test cases that we should be running at the UI level. So maybe you're just P1 and P0 test cases. So say, for example, you have functionality like a login page. You'll want to automate the test cases that absolutely just cannot break. So you'll want to automate something like, can a user with valid credentials be able to log into the system? And then another one might be, if a user has the wrong password, are they not able to log into the system? So those are the types of things that we would test. Like, what are the most important things that just cannot break that we would look at testing at the UI level? So now I'm going to talk with you about a couple of the different types of UI tests that we run at Amazon. So I mentioned a couple previously, but here's a couple others that are out there. So just some functional test cases. So at Amazon Local, we want to make sure that somebody can get through and then place an order on Amazon Local. So we have a test that validates that. We might have a test that validates that the price is correct, that you do something that would update the price of an item, and you want to make sure that that's properly reflected in the UI. And then we might have some negative test cases in there, like the can I order a sold out item? So if an item is sold out, you want to make sure that somebody can't go through and then purchase that sold out item. So those are a couple of the functional test cases that we might run at Amazon. So in addition to those functional tests, we might actually do some display tests. So what we do in the display test is we'll actually take a screenshot between our beta environment and our production environment and programmatically compare those two screenshots to see if the two environments have changed. Like maybe we're pushing out some back-end service change, and we want to make sure that the UI hasn't changed as a result of that. So what we'll do is we'll take the screenshots of our beta and then production environments, and then we programmatically compare them. And then we'll get a difference count on the number of pixels between the two images. And if it's above a certain threshold, we might fail the test. So in this example here, we have our production environment that's over on the left, and then our beta environment on the right. So we'll programmatically compare those two images, and then we'll also spit out a third image that actually shows us the difference. But sometimes it can be actually fairly difficult to figure out. Like you'll notice that there is a pixel difference count, but you can't exactly figure out where that pixel difference is. So we'll spit out an image like this where it actually will highlight, it'll highlight the actual pixel differences between the two images. So what do we use for automated testing inside of Amazon Local? So how many people in the audience are familiar with Selenium WebDriver? OK, so it looks like it's a pretty good chunk of the population here. But so Selenium WebDriver, for those of you that don't know, is an open source UI testing tool. It allows you to natively control browsers. So you can do things like fill in forms, click links, navigate backwards and forwards, and then check various different elements in the page. It has implementations for Firefox, Chrome, Internet Explorer, Safari, Opera, and then most of the mobile browsers. So you can do automated testing on a good series of the different browsers that are out there. It's also been recently proposed as a W3 standard, which you can read about there if you're interested. And it's fairly ubiquitous in the industry. Amazon obviously uses it. Google, Facebook, Apple, Microsoft all use Selenium WebDriver. So the next thing I'm going to do is I'm going to just show you some code, and then I'll do a little bit of a demo. So this code is written in Java. So what you can see what I've done here is on lines 1 and 2, I declare my test annotation, and then my test method declaration there on line 2. On line 4, what I'm doing is I'm launching an instance of the Firefox browser. Lines 5, I'm navigating to the Las Vegas implementation of the Amazon Local page. Line 6, what I'm doing is I'm clicking the sign-in button at the top of the page, which is going to direct me to the Amazon.com login page, where I'm going to enter my email address and then password, and then click the sign-in button. So in this test, what I'm doing is validating that I can click on the sign-in button and then get to the Your Orders page, and then I'm validating the title of the page. So on line 12, this is actually what's called an assert, for those of you that aren't familiar with what asserts are. But this is where I'm actually doing the actual check part of the test, where I'm saying, does this match this? So is anybody in the crowd familiar with JUnit? OK, so can anybody see the bug in my code? Does anybody see it? OK. So anyways, the bug is what you're supposed to do in asserts in JUnit is you're actually supposed to have the expected value on the left and the actual value on the right, and I got those swapped in my demo. So, OK, so now I'm actually just going to do a quick demo. OK, so here's the test. It's essentially the same code that I had on the slide. There's a couple things that I've done differently, though. I actually added some sleeps in here, so it'll go a little bit slower so you can actually see what's going on. And it's actually going to fail the test because the username and password that I have in here are obviously not real credentials. But you can kind of see what's going on. So you'll notice what will happen here is it's launching the Firefox browser. It'll click on the sign in button on the upper right-hand corner of the screen. It'll enter the email address, the password, then it clicks on the sign in button. And then you can see that it obviously didn't get past there. So then if I go back over to Eclipse, you can see the test has failed. Is it 6? Or is it 7? Yeah, there we go. OK, so the other thing that we use at Amazon Local is we use what's called a Selenium grid. So this allows us to actually run our tests on a machine that's different than the machine that's actually executing the test. It also allows us to run our tests in parallel. So essentially what happens in a Selenium grid is that you will have a hub that will communicate with various different nodes. And those nodes could be various different physical machines, virtual machines that connect to the node that have a certain number of browser instances that are available. So what will happen in a common scenario where tests are executed, that you'll have tests on a specific machine that are executed, and what they'll do is they'll reach out to the hub, and they'll say, like, hey, I want to run these commands, these Selenium commands. What the hub does is it'll queue the tests at the hub until a browser instance becomes available on the various different nodes to run those various different commands. So I'll just kind of walk you through a quick demo here. So we'll have some Selenium commands that we want to run. So the tests are going to send those commands over to the hub. They'll be queued at the hub until the browser instance becomes available. Once the browser instance becomes available, then it gets sent over to the node. So now, how do we do this at Amazon? So one of the things that we've done with Amazon, or when we were looking at setting up this grid, a Selenium grid for Amazon Local in Amazon, what we wanted to do was actually kind of not go with a local approach for our testing. We didn't want to build like a device lab that has various different browsers and various different machines sitting in a closet someplace in Amazon. We wanted to take our testing infrastructure and then move it to the cloud. So my team, I'm a quality assurance manager. I manage quality assurance engineers. My team's core competency isn't in building physical hardware. So I wanted to offshore as much of that as I could. So that's why we looked at using Amazon EC2 for hosting of our grid. So what we've done is we've actually moved the hub and then the various different browser nodes, the different nodes into EC2. So we have, with EC2, we have Windows versions 2003, 2008, and 2012, which give you access to IE versions 9 through 11. And then they also allow us to install the other various browsers, Firefox and Chrome, for whatever versions that we need. So like I was mentioning on the previous slide, tests are queued at the hub. But what will happen is if you have thousands of people that are running the tests, you could see a lot of tests just getting bottlenecked at the hub waiting for browser instances to become available. So what we've done is we've created AMIs for our various different nodes, and then we can add those to the grid as needed to increase or decrease the time at which the tests run. So if we need to add various different nodes to it, we can do it very easily. OK, so how are tests executed? So tests are executed at a number of different ways at Amazon. So the first way might be that a developer would push code to a beta environment, and then he wants to run the test to make sure that the code that he pushed to the beta environment is working properly. So a developer might execute the tests on his or her desktop and then have them run against the beta environment. They might also run on a schedule. So say they want the test to run at 1 o'clock in the morning They might set up like a cron job or something to have the tests run at a specific time. And finally, they might, there's been a lot of talk this week about continuous deployment. So they might run them as part of a continuous deployment process. So for those of you that aren't familiar with continuous deployment, the way that I like to view it is a combination between continuous integration and continuous delivery. So changes made by software developers are automatically integrated, tested, and pushed to production without any human intervention. So some of the tools that were announced at the keynote this week, code pipelines, code deploy, are things that are tools that we've used internally at Amazon that help us in our continuous deployment process. OK, so I'm going to end it here with just a little bit of trivia. How many minutes of automated UI tests have been run at Amazon since July 1st? So 200,000, 300,000, 1 million, or 10 million? Can anybody take a guess? So it's close. So it's actually 1 million. So we've run over 1 million automated tests on EC2 since July 1st. So I'm going to hand it back over to Leo. And if you guys have any other questions, feel free to just meet up with me at the end of the presentation.
So now we're going to talk about load testing. So on AWS, you can easily spin up a load test environment really quickly and then turn it back off when you're not using it. So you can use spot pricing for this. That might be a good strategy for cost optimization there. But it's really hard to do this on premises. So let's talk about some of the differences between load testing on AWS and load testing on premises. So on premises, it's really hard to replicate your production environment. I mean, you could test your production environment that you have, but if you're not really confident in your production environment, you might break it. So if you want to replicate an exact copy of your production environment, you have to have just as many servers and switches and all that stuff as you do in your production environment. So that's going to get expensive and difficult. Also, you're typically dealing with a limited set of IP addresses you're testing. So you might have a load balancer. You might have 2 load balancers for HA. They might share an IP address or have 2 IP addresses. So that part is actually, that's a little bit different than on AWS. And you can have bottlenecks in your network layer. So if you saturate your load balancers, network capacity, for example, on premises, you're going to have to get a bigger load balancer. It's really hard to get past that without buying new hardware. On AWS, you can replicate your production environment really quickly and really easily. And you only pay for however many hours of it you use. You can use spot pricing sometimes, depending on how you set things up. So you can do a lot of things there. You can use automation, so you can use CloudFormation or Chef or Puppet or OpsWorks or Elastic Beanstalk or some combination of those things to recreate exact copies of your production environment. That's really important because the only way to actually accurately load test is to have an exact copy of what you're doing in production. Each layer of your app can be designed to be scalable. So you can auto-scale your web tier, your app tier, your Elastic load balancers scale themselves, which we'll talk about in a little bit. And your IP addresses are going to be variable. So that's really important. And that changes how you load test. So on Elastic load balancers, it's a scalable service that scales in the background. So you have a static host name, but you don't have a static IP address. The underlying IP addresses of ELBs can and do change depending on how much traffic is going through it and how it's scaled up and down in the background. So that's going to be really important. You don't want to be just testing against one IP address. And the horizontally scalable nature of EC2 allows you to scale past network bottlenecks. So each instance that you're running has a certain amount of network capacity, but you can horizontally scale. You can add more instances. The VPC doesn't have any level of network capacity attached to it, so you can just keep growing horizontally and not have to worry about that. So let's talk about load testing against Amazon Elastic load balancers. So when you're testing against regular load balancers, you typically ask some questions. How many application servers do I need to support various levels of traffic? So how many servers do I need? That's what the goal of your load test typically is. How many load balancers do I need, right? So is my load balancer, can it handle the capacity that I'm throwing at it? Or do I need to upgrade my load balancers, get bigger load balancers, get more load balancers? And what happens to my application if there's a network failure or a hardware failure? So you want to simulate failure states. What's really nice is with Elastic load balancers, 2 of these questions don't really matter. So you want to test if your application can scale up or not. You want to use auto-scaling groups. But you don't really need to know, how many application servers you're going to need. You're going to need to know whether you can scale up or not, and whether you can scale down properly. How many load balancers do I need? Again, ELBs take care of that for you. So you just provision the ELB, and it'll grow and shrink with the traffic that's being thrown at it. You do need to know how your application is going to continue to operate in the event of network failure or hardware failure. So if your instance fails or if one of the availability zones has some kind of issue. So that's really important to test for. And you should test with the assumption that any one thing can fail, so you don't have any single points of failure in your architecture. So just some other considerations for load testing against ELBs. First of all, DNS. So again, do not test against your Elastic Load Balancer's IP address, because that will change, and you might test against somebody else's ELB eventually. You might not get an equal distribution of load because you're just testing against an IP address that's in one availability zone. And you want to ensure that your DNS is re-resolved, or you want to use multiple test clients, and I'll show you how to do that. So when you resolve the hostname of an ELB, you'll get multiple IP addresses, so you don't want it to hit the same IP address every time. You want it to not cache the DNS and get the results every single time it's doing a test, because then when you run your actual test, it'll have an equal distribution of load. You want to think about sticky sessions. So if you have sticky sessions in your application, that can cause your load not to be equal behind your load balancer. So you want to consider your different things there, right? For whether you have sticky sessions, if you can disable sticky sessions ideally. And you want to think about your traffic growth. So if your traffic growth is slow and steady, the ELB will scale for you. If your increase of load on your ELB is more than 50% every 5 minutes, you're going to want to do what's called a pre-warm. So if you have spiky traffic, basically, you're going to want to put in a ticket with AWS support and say, I would like to pre-warm my Elastic Load Balancer. Here's the amount of traffic I'm expecting per second. Here's the average request size. They might ask you some more questions, and they'll pre-warm it for you. So that way, it'll be pre-scaled, and you can then handle the amount of spiky traffic that you're expecting. You're going to want to think about instance sizing. So like I mentioned earlier, each EC2 instance has different network art attached to it. In general, the instances, whether it's a C3 or an R3 or an I2 that end with 8 extra large, they have 10 gigabit networking on them. So that's the most networking you can currently get on an EC2 instance. So if you're going to be sending a lot of bandwidth, a lot of traffic from any one instance for the load test, those are the best instances to use. You want to make sure you're enabling enhanced networking. So the C3, R3, I2, and now C4 instance families have something called enhanced networking. This allows you to get lower jitter, higher packets per second, and lower latency. And it's a free feature. You just have to make sure it's enabled. It's enabled default on Amazon Linux AMIs, on other distributions, and on Windows. There's directions on our documentation on how to enable that. So make sure you have that enabled. And again, load testing is a really good case for using spot instances. You can spin up a bunch of instances with spot pricing, and you can then save a lot of money over the on-demand price. And if you lose some of your instances because the price goes above your bid, it's not a big deal. It's a load test. You can fail back to on-demand if you have to. So what I want to show you here, there's a lot of commercial load testing tools out there. And they're all really good. I'm going to show you some open source tools that are free that you can easily use. I'm going to spin up an auto-scaling group with those load testing tools in them. And so to bootstrap my instances in my auto-scaling group, I just have this really simple shell script. So what I'm doing is I'm on boot. It's running this script. I'm updating all the packages. I'm running an Amazon Linux AMI. If you wanted to do this in Ubuntu or Debian-based Linux distribution, you just basically change out yum for apt-get, and it should be pretty similar. So then I'm enabling the EPEL repository. That's a repository with some extra packages in it. And then I'm installing the tools that I want to get. So almost all the tools I'm showing here except curl loader, I can just get off of RPM. So I'm installing AB, which is Apache Bench. I'm installing Siege, which is another load testing tool. And I'm installing all the stuff I need to compile curl loaders. So GCC, AutoMake, AutoConf, all that kind of stuff. And then I'm downloading curl loader. I'm extracting it. And I'm just making and installing it. And this runs as root, so I don't need to do sudo anywhere because I'm going to put this in user data. So then I'm making an auto-scaling group. So all I did here is, again, instead of putting that script in user data, I might want to change something with that script, and I don't want to have to change my user data each time. So I put that script in a file in an S3 bucket, and I'm just getting that file from my S3 bucket, giving it execute permissions, and I'm running it on boot. So what this allows me to do is, if I want to change the script, I just change it, upload it to my S3 bucket, and I don't have to change anything on my auto-scaling group. It'll just get the latest script. So I've created my auto-scaling group. I'm using C38XLs. Yeah, you can use other instance types. That's the one I chose because I wanted to have a lot of network capacity. I'm not really doing anything else special here. I'm making sure each instance has a public IP address, and it's going to be on a public subnet in my VPC. And I'm running the default stock Amazon Linux HVM AMI. So I've created my launch configuration, and now I'm going to create my actual auto-scaling group. So my auto-scaling group is going to default at 0 for a minimum size and a maximum size of 200. I might want to scale it up really big. And it's going to be across 3 availability zones. And because it's 0, it's not going to cost me any money unless I'm actually using it. And so if I want to use it, I just change my minimum and desired capacity to whatever I want it to be, and it'll start spinning up instances and bootstrapping them. This auto-scaling group doesn't need to be in a load balancer, so it's not attached to one. So the first thing I'm going to demo is Apache Bench. Apache Bench is a really common tool that's out there. And so the thing with Apache Bench, though, is it caches DNS. So you're going to want to run it across a lot of instances, such as in this auto-scaling group. So it's going to be coming from a lot of clients. So let's do an actual demo, and I'll show you what I did here. So I'm just going to switch over my screen. So OK, so here we go. So what I'm using is I have a Fabric script. So Fabric is just a Python framework for running parallel commands. And I've written a little script that allows me to pull out the host names from my auto-scaling group and run SSH against all the host names. So whether I have 2 instances or 20, it'll automatically run a command that I want on there. So what I'm going to do here is I'm just going to run my Fabric script across all these instances. So I've got just a stock WordPress install that I set up with Elastic Beanstalk. And it's got an RDS instance and one regular instance, and so it's not doing anything really special there. And so what I'm going to do is I'm going to run Fabric. So let me up the font size here a little bit. So I'm going to run it as the default user, so it's going to be EC2 user. I'm going to run it in parallel. I'm going to run it on my load testing tools auto-scaling group, and I'm just going to type in the command. So I'm going to run Apache Bench. I'm going to run 100 tests with a concurrency level of 20. And I'm going to run them on my demo WordPress here. So oh, I have a typo. 1 second. There we go. So see, it's got all the host names of all of my instances, and it's running the same command on all of them. So it's going to run this command. Here we're going to get the output from all the instances. And basically, when it's done, what you're going to want to do is you want to add up all the results. So I think I have 10 instances. So you're going to want to figure out, well, I'm doing 100 requests per instance. That's 1,000 requests and a concurrency level of 20. So I'm actually doing a concurrency level of 100. And if you look at your ELB CloudWatch logs for this, you'll see that the traffic is going to be equally distributed because it's coming from 10 different instances across 3 different availability zones. So here we go. It returned the results, and that's really basic kind of load test. So now let's talk about Siege a little bit. So Siege is a different open source load testing tool. The cool thing about Siege is that you can give it a list of URLs. So what I've done here is I have another WordPress install that I use for demos, and so I put both of them in here, or you can just put multiple URLs or pages from the same website. So whatever, just a text file with different URLs in it. And I'm going to run Siege again across my auto-scaling group, and I'm going to run it for 1 minute, and I get a concurrency level of 100. So switch back here. Okay. So now I'm going to go back here, and I'm going to just run, instead of running Apache Bench, I'm going to run Siege. So 1 minute. And if you notice in my Bootstrap script, I didn't have my URLs there. So what I ended up doing was I just put the URLs into an S3 bucket, and I just did a wget for that URL for the S3 bucket from all of my instances. So now I'm running siege. So it's going to run this command, and it's going to start giving me output. And so that's another way to do a load test. So again, the nice thing about siege is it's got a little, if you do siege minus help, it's got a little bit more options there. So it's going to take a minute. So it's going to keep running. So let's talk about curl loader. So curl loader is another good tool out there. So curl loader, the cool thing about curl loader is it can simulate multiple clients. So you can give it multiple IP addresses. So the way you would make this work on an EC2 instance is you attach multiple elastic network interfaces to your instances. You give them each a different private address. You give them each a different elastic IP address. So your instance is going to have multiple elastic IPs. And then you just set up this config file here. So the config file just tells it how many clients you want to simulate, what the IP address space is, how many cycles, so how many times you want to test, and what you're actually testing. So for this one, this load test is still going, but I actually wanted to show it just on one instance. So I have a different instance here because it's got different elastic network interfaces on it. So I'm going to SSH into my instance. It's probably going to be, yeah, there we go. And so I'm just going to run curl loader. Now curl loader has to be run as root, so I'm just going to do sudo. Here, let me actually show you my config file here. So I've got my curl loader config file. I have got 2 of my IP addresses on my instance loaded in here, and I'm load testing the same URL I was before. So I'm just going to run curl sudo curl loader, and all you have to do is give it the config file. So it's going to start running, and you can parse these results later. So let's see if my other load test is done here. Yeah, it is. So now I've done my load test. So this, the siege actually gives you, what your average time is, how much data has been transferred, how many transactions per second it was able to achieve, so all kinds of useful information. So let's talk about load testing against CloudFront. So again, CloudFront, it also has multiple IP addresses. When you resolve a CloudFront URL, it is in it's going to give you a bunch of latency-based results, right? There's, I believe, 53 edge locations for CloudFront at this point, so it's not within a region. It's all around the world. So to really test against CloudFront, you want to use multiple clients, ideally in multiple regions. So you can take something like what I've done here. You can write a little CloudFormation template on it that recreates the auto-scaling groups and the user data, and just launch it in a bunch of instances across the world. And again, you don't want to cache your DNS, because it's really important to be picking up fresh DNS. So a really good tool to use, both with CloudFront and ELBs, is called Bees with Machine Guns. So this was it's an open source tool. It was created, I believe, by the Chicago Tribune tech team. And it's really easy to install. So it's you would run this command on your laptop, actually, or whatever your testing machine is, because it doesn't do the actual load test from your machine. It spins up a bunch of instances to do it. So you just do pip install bees with machine guns, pretty simple. Then you spin up a bunch of bees. The bees are spun up are T1 micros. So this command here would spin up 4 T1 micros. You specify your security group that you want them to be in and your key. And then in a few minutes or less than a minute, it'll spin up your actual bees, and then you run your attack, right, against your website. It's really important to do this against your own website. If you're doing it against somebody else's website, you're going to hear from our security team. What I've tested here is I have another WordPress that's slightly more fancy. It's using Elasticache and multi-ZRDS, and it's an auto-scaling group, so it can take more traffic. So I'm going to send 10,000 requests at a concurrency level of 250 at a time here. So let me show you how that actually works. So in the interest of time here, I've already spun up my bees. So what I did to do that was just I gave it my key. I spun up 10 bees. I made a security group called bees that can accept that SSH connection, so we can actually connect to these things. And I'm targeting a certain availability zone for them. So now I want to actually do my attack. So in the interest of time, I'm going to do a little bit less traffic here, but I'm going to do bees, attack. I'm going to do 1,000, concurrency level 500. And I'm going to give it the URL. There we go. So see, my bees are already running. So they've already run their tests. So in this example, my target easily took that level of traffic. Now, if I want to make this more interesting, again, we can do say 10,000 with a concurrency level of 500. So each bee is going to fire 1,000 rounds, 50 at a time. This will take a little bit more time here. And hopefully, it still won't knock over my website. But if it does, I will have learned an interesting lesson about it. So, all right, so it looks like I was doing about 747 requests a second. I was getting about half a second response time. So that's pretty good, right? So you basically want to keep testing it until you actually break your website. And so you know what's actually broken, how to scale up from there, and what capacity you have. So how do you actually know when you're testing against CloudFront whether your cache is working, right? If your CDN is just passing all the traffic back to your origin, you're not really taking the advantage of CloudFront, of a CDN. So we've got a popular objects report in CloudFront. So what that allows you to see is like, what are the most popular objects against my distribution? And what's really important here is you want to look at the hits and misses. So a miss means it had to go to the origin for your request. So that means it didn't get cached. And a hit means it just came straight out of cache. So if that, you get a lot of misses, you want to look at what are your cache headers for your objects. So for example, for things like CSS files, JavaScript, HTML, you probably want to have like a 24-hour at least cache on them. So you can configure that in your Nginx or Apache or IIS. We also have a report called, this is a new feature actually, so you can get a bunch of statistics. So the one that's really important here is you want to look at data transferred from the CloudFront edge to your users. That's how much data is going from the edge locations to your actual users. And you want to compare that to how much traffic is going against your origin. So here's an example CloudWatch chart of network out from a whole auto-scaling group. And that should ideally be a fraction of what's actually coming out of CloudFront. So that means your caching is actually working. And you can get all kinds of statistics that are grouped by auto-scaling group. There's different CloudWatch metrics you can get from ELBs. So there's all kinds of useful stuff you can do here. So then how do you test if your auto-scaling groups are working? How do you even know when you're scaling up or down? Refreshing your console isn't super efficient, right? So you probably want to create auto-scaling notifications. So using that CLI command, first you want to create an SNS topic. You want to subscribe to that topic. And then you want to run that command, and then you'll get a notification every time there's an instance spun up or shut down by auto-scaling. You also get a notification if it fails to launch for some reason. So that'll actually tell you if your auto-scaling is working or not. So the other thing you want to do is you want to make sure you're using the right trigger for your auto-scaling. So if you have the wrong trigger, it's never going to scale up or down, and your website could not be functioning right. So this is an example of a CloudWatch metric for CPU utilization. And so you see we hit 100 CPU there for about an hour. So that's an example of CPU bottleneck. So if you do a load test and you see that your instances are bottlenecking on CPU, you want to make your auto-scaling trigger CPU usage. So you'll say, if my CPU usage is over 85% for 10 minutes, launch more instances, right? It could be, you could use other metrics as well. You could use custom metrics, so you can inject a custom metric and have your auto-scaling trigger off of that. But whatever it is, you want to make sure you're actually triggering off the right thing. And then the other thing that's important is while you're doing your load test, it's cool to see how much traffic your website can sustain, but you want more data than that. You want to see what's actually slow. Do I need to scale up my database? Or do I need to scale out my database? Do I need to get more instances? Is it PHP, something in PHP slow? Is there a slow query? So there's a lot of good third-party tools out there for that. In the expo hall, I'm sure if you walk around, you'll see them. Just to highlight a few of them, so New Relic. New Relic, you run an agent on your instance. There's a server monitoring agent, and then there's an agent that runs inside the actual application. So it supports PHP and Java and Ruby and Python and Node.js. So you basically run this agent, and it'll give you some really good insights. So here it's showing you, it's breaking it down by database, by .NET, by queues. If you have memcached, they'll show you how much time things are taking memcached. So you can also set alerting based on this. So you can emails when your application isn't performing well. So it's really important to look at something like this during load test. It also has an app score, so it kind of rates how responsive your app is. So all kinds of cool features there. And it's easy to integrate with auto-scaling or with Elastic Beanstalk because you just install the agent on boot and it'll start reporting up to the New Relic service. Boundary is also agent-based. That's another application monitoring solution. Boundary gives you some really good insight about how much data is going between different layers of your application on the network layer. So just to conclude here, you want to test your application at every level. So you want to test your UI, which is what Dave talked about. You want to do load testing, and you want to do performance monitoring, right? So you want to see, what lessons did I learn from this? And AWS allows you to do realistic load tests really easily. I have customers who spin up hundreds of instances, to do a load test and then shut them down. That's totally normal, and it works great. And most importantly, testing inspires confidence in your app. If you can show some hard data to your managers, to your customers saying, I've tested this out, my application can sustain this level of traffic, we've identified these weak points, we've mitigated them, it's going to make you more confident, it's going to make your team more confident, and it's going to result in a better application. And lastly, it allows you to exercise your actual scaling scenarios, so auto-scaling. How do you scale up and down? It's really important to make sure that's working, because you don't want to find out that's not working as it should when you're in production and you actually have to scale. So that's our talk. Thank you for coming. We're going to take questions out. There's a question booth out there afterwards if anyone has any. Thank you.